So yeah, we're talking standards and why we use them. So who am I? Why am I here? I'm a developer working for a company in the UK called Jump24. My Twitter's there, my email's there, the company website is there. We're currently recruiting across the board, remote positions, but you must be UK resident. We work with Laravel and CakePHP using test-driven development. So why do we need standards? We have a lot of systems that we use. When I say a lot of systems, I mean a lot of systems. We have CakePHP, Terraform, AWS, PHP, Nginx, Laravel, Inertia, React, SAS, MySQL, Redis, HTML5, CSS3, JavaScript, Webpack, and Docker, and that doesn't cover all of the things that we use. So the key takeaway for today is that standards help. They enable developers to work together better. It simplifies code review, and it keeps code consistent across projects. So we're going to talk about specifically the PHP standards that we apply, because that's mainly what's going to be relevant for us here. PHP standards are our centerpiece. We use Linter, ECS, PHPStan, and we use test-driven development. On Laravel projects, we will use Enlightn, but at the moment that's Laravel specific. We think of everything we do in the terms of hit by a bus scenario. If a developer was not available tomorrow, could someone else pick up their work? Or as the image shows, can you actually pick up your own work? On a Friday evening, the number of times where I've said, I'll finish this Monday morning, come in Monday morning and go, I have no idea what my own code means, is unbelievable. So let's take a look at our first one. Let's look at Linter. So let's get a bad code example. At first glance, this code might look okay, but there's actually a couple of errors here. There's quite a few of them, really. So if we try and run that code, we'll actually get an error. And the error is that it's expecting a semicolon or a comma in the function. But that doesn't really tell us much other than it happens to be on line 5 and what it's expecting. So we bring in a couple of packages. We'll start by bringing in parallel_lint and console highlighter, and we'll set ourselves a script up, which is lint. Then we'll run it. And if we do compose a lint, you get a much better explanation of what's going on here. And because we're developers, we love seeing red as an indicator of an error. This gives us errors in the files that it's processed. In this little test app, there was literally one file that had that function. And it's telling us that the error is on line 5. It's pointing out what line 5 looks like to make it easier to find. So let's fix the code. We fix line 5 by taking in the other message that we're expecting to see. We put the semicolon at the end of the echo for the constant, and then we actually run the function. And then if we run that code again, we find that it actually works and we get our output, which was something else. So we actually have our own standards packages. These are available on Packages for anybody that wants to use them, and we get to enforce our own particular coding style. We bring in the packages we need, so the two that we already had. We then bring in PHP coding standards and project analyzers. We'll set up some scripts. So we've got the lint that we already had. We have ECS, which I'll come back to in a second. We have static, which is PHPStan, and then we have test. In this instance, we're using pest, and PHP unit will work just as well. We set ourselves up a PHPStan file. In there, we're defining our own PHPStan file from the PHP coding standards. We also create ourselves a blank PHPStan baseline. We set the level to the highest level that we can, which is 8. We exclude a few things because we don't necessarily want it checking vendor. We also don't necessarily want it checking IDE helper output. ECS. ECS is Easy Coding Standard. It's built for making it easier to set up coding standards for PHP developers. And the main thing with this is import the standards that we've defined in our ECS file in the package. We set some parameters that tell it which directories we want to look at. So in our case, we want to look at app and we want to look at tests. So what are we doing here? Linting, static analysis, and coding standards. Why linting? It highlights code errors. It tells us very easily where the code errors are. Sometimes these errors will slip through without you even realizing. Most IDEs these days will actually point out the errors for you, but occasionally we miss them. Why ECS? It allows us to ensure our standards for code are met, extending this easily and allows for in-editor highlighting of custom standards. So we can actually hook this into PHPStorm, and PHPStorm can highlight ECS's own standards and our own standards within that. So what standards do we apply? We apply PSR 12 and other related standards. We'll also apply some external standards. Squiz Labs is one that we use regularly, as well as some of our own. Why PHPStan? We just find that it integrates better with everything. It allows for static analysis. It helps to strengthen our code, and it just makes our development process easier. If these are run before it gets to a pull requests just become so much easier to handle. So let's try it out. What could possibly go wrong with live code? We'll switch over to the little app that I've built for this. As you can see, front-end development is not my strong point. So at initial glance, we can see that this looks to work right. We can get our articles here. We can get this article down here. But let's go and log in. Now, in this case, I'm already logged in with my user, but actually we've got a syntax error here. So imagine the scenario that this had got to production, and this is an error that somebody sees on production. Admittedly, they wouldn't see it with the debug screens. So let's go and take a look at how we might be able to make use of this. So the first one we'd want to look at is, as we said, let's look at composer lint. So in this case, we'll run the lint command. It takes a couple of seconds to pick up. It runs through, and it actually gives us our error. So in this case, we have our error in the dashboard controller. Let's go and take a look at the dashboard controller. So we'll head over to dashboard controller, and this is just picking up a nice simple error. In this case, a missing semicolon. As I said, most IDEs will actually give you the error in the IDE. In this case, it's highlighting that for me right at the end. But let's just assume for a second it didn't. It was easy enough to find because this told us exactly what the problem was. It told us that when it tried to read line 19, that it didn't expect to see this. So it was expecting a semicolon before here. Okay, so let's see if there's any more errors there. Let's run that again. Excellent. So we've got a clean application from a linting point of view. And that would have been one thing that's saved from going to production, just a simple missing semicolon. Let's take a look at the next one. So if we clear the screen and do composer ECS, which is the other command that we've got for checking code style, we run ECS. We'll always run clear cache, simply because clear cache tells it not to ignore things that it has seen before. So in this case, we've got an error over here, which is in article save new controller. So let's open up save new controller. Here, this is another of our standards that we're seeing in place. We will keep controllers as slim as we can, and we'll keep them to a single action. We'd rather have 100 controllers doing one thing than one controller doing 100 things. Let's take a look at this code. So what this is highlighting to us is the return this redirect here. So this is highlighting a code style point that we work on, which is we would prefer to see arrays and functions split out, and it's telling us that that is what it would want. Now, sometimes these things can take a long time to work through. So there's an additional step that we can use. So we could do vendor bin ECS clear cache check. So that's telling it to clear the cache, fix anything that it can, and run the check. We run that, and it goes that it's fixed that, but as you can see, it's actually not necessarily done the perfect job of this. So let's run ECS again and see if it still complains. So it is telling us that there's something else we can do here that can be fixed. And if we scroll back, it's telling us that there's a missing comma, which again, it can fix for itself if we run the ECS fix. And you'll see that in the IDE, it's added in the comma for us. So now it's telling us that there's a couple of things that we need to fix manually. Let's run ECS again, just to check that that's all we have left from ECS. So actually it's telling us there's one to fix manually. So as far as ECS is concerned, it's solved the problem for us. However, it's pointing out another problem here, which is an unused parameter. So sometimes we'll have code that we've edited previously that we may want to make a change to that takes out the use of an article ID. So for example, in this case, I actually copied the save controller for edited articles, which does need the article ID when I was creating this controller. And when we go to the save new controller, we're actually not using that. So this is pointing out that we have an unused parameter, but it doesn't know whether you want to use the parameter or whether you want to remove the parameter. Now in our case, we'd scan down the code, we'd check that we've not mistyped it, not misused it, and we haven't. So we can just remove the parameter manually. As I said, ECS isn't perfect in fixing everything that we would do. In this case, we would normally have this laid out clearer like that. So if I run ECS again, we should now get a clean run. Now at this point, we're already showing that there's two commands to run here. What I normally do when I'm building things like this is I'll build a before push. This before push will run every command that we want it to run before it pushes to GitHub. So if we do composer before push, we should now see that it will go through the first two steps. So linting passes, it will now run ECS, which passes, and now we get to PHPStan. So PHPStan is extremely quick at analyzing code. We can see here that there's 13 errors that it found. So let's take a look at these errors. We'll go back to the beginning. If we go back to the first one, we're in ArticleEdit Controller. Okay, so let's find our ArticleEdit Controller. And that's over here. So ArticleEdit is here. So the first point it's saying is parameter one ID of method getById expects an integer but string given. So let's check that Stan has got this right. So if we go over to our function, we can see that getById does indeed expect an ID. This is using PHP 8, so we've been able to do union types, which is saying it can return null article or entity interface. So in our case, it expects ID to be an integer, but it's not. It's coming through as a string because this is currently using this slightly older version of CakePHP, which is stuck with the issue of string. So with the newest version, we'd be able to solve that by changing that to integer. But in this case, because we have a string that's then being passed in here, we could just do integer. But actually, I think that creates us a slightly different problem. So we'll do an isNumeric on article ID. And actually we want not is numeric. So here we're going to add in an extra catch, which allows us to make sure that we are returning back to our dashboard and helpful error that says the article ID passed was not numeric. Once we are able to upgrade this to the next version of Cake, that section would not be needed because we're then hard typing it to an integer. The roots for this does actually have this typed as well using the regex, so it would actually pass without that. But again, it's double checking, making sure that our standards are being met and that we're catching every possible error we can think of. So here you'll see that we'll get by ID from the article repository, and we'll check that the article is an instance of an article. If it's not an article, we'll return back with an error. Otherwise, we'll set the compact variable and we'll render. So that fixes this controller. We can see that line 23, it's expecting response or null. So the reason it's expecting response or null is because redirects can return a null. So again, using PHP 8, so we do response or null. If you're using anything before PHP 8, you use a slightly older version of the question mark response, which is a null safe variable. So in our case, we'll do response null. So that fixes the two errors here. Let's take a look at the next one. So here we can see that article save controller is actually giving us the same problem, which is the ID expects to have as an integer and it receives a string. So again, we'd actually add in the check here and we would cast to an integer here. So we'll grab the check that we've just done because it's the same check. Like that. But at this point, we could actually consider that we're repeating code here. So two controllers are doing an isNumeric check. We would potentially consider this being a middleware that would check that what we're receiving is numeric in this instance, or we could rely on the routing to do that for us. For now, let's leave it as repeating the code. So article. Here we've got an error on a function. So this is actually picking up on a return type again. So let's go and take a look at that function. Let's open article and take a look. So we've got a predefined length of 512. We're grabbing this body from the article entity. If the string length of this body is greater than length, then we'll do a regex replace of the maximum of the length of 512, add 3 dots on the end of this body. The problem here is that preg replace could actually return a null, or it could even return a string array. So here we'd want to be looking at catching a different type of error. So if is null text return body, which is one way we could handle that, but normally we wouldn't necessarily use the function because it can make it a little more difficult to read. So we could do text is exactly equal to null. But now we're not sure that we've actually still got a string here because you could have had an array. So we could at this point do an extra check underneath that text is a string, but in this case we actually know that text is a string because it's coming from the model. So what would you do in this sort of scenario where PHPStan seems to be suggesting things that you might not need to do? Well, we'll revisit that in a second because we've got a few more different errors that we might want to look at for this. So let's open our articles table. So if we open our articles table, we've got get by slug. Here, it's telling us that it would return entity interface or null, but it returns array entity interface or null. And that's for get by slug. So let's take a look at the slug. So this is saying that it would return an array. In our instance, it probably wouldn't return an array. It's theoretically possible that it could, but it's very likely that it won't. So this is another example of PHPStorm could be picking up on something that we don't necessarily want to change. Get all by user ID. We're telling it to return result set, but actually it wants result set interface. Now, again, this could be solved in a slightly different way. We could make use of the IDE helper, which would resolve that for us automatically. Or we can just tell it that it actually is a result set interface. The next one is should return entity interface or null, but it actually returns array entity interface or null. So this is the same problem as we saw with the first of these functions. So you've seen me in the controllers using a set of functions, this articles repository, which is passing through to our table. We actually create a trait for that which is access repositories. So if we take a look at that, you can see that in this instance, what we do is we check if articles is set. If it isn't set, load the model and then return the articles. This is something that we do simply to avoid needing this load model in every controller and having articles repository available. But here, the error is in our users table. So what we're doing here, we're checking if this users is set or this users is not an instance of repository interface. Well, that's always going to be true because it's either going to be set and be a repository interface, or it's not going to be set and not a repository interface. So we don't actually need that second check. PHPStan here is simplifying our code by telling us that that second check isn't actually needed. So we can remove that, which resolves that check. The other issue that we've got is that's the repeated issue again in access repositories for the article save controller and again in article save new. So this is where PHPStan will help by telling you the context that you have for the error that you are seeing. So it's repeating this error 3 times for us, but you may end up in a position where some of these are actually not errors and you do need it to act in a certain way. So we've got a 4th instance there, a 5th instance there, and a 6th instance there. So for a minute, let's have a look at what happens if we run before push again. So Linter passes, ECS is now telling us that there's some errors. So this is where repeatedly running things will help. It will tell us that there are new errors that have been made by your changes. So in this instance, it wants us to look at articles table. The first one is an unused import, which again, IDEs will often highlight for us. But what if your IDE is one that doesn't highlight this? It's telling us cleanly that that's the case. We'll remove that, which resolves the first one. The second one is another one in access repositories of an unused import. This is another one that ECS can actually fix for us. So we'll do vendor bin ECS check, clear cache, fix. And I've just realized I've typed check twice, so it's going to complain at us because it thinks I want to look at a source code called check, which is another point with ECS. You can actually have it look at a single file. So to have it look at a single file, you just pass it a path. In this instance, it's fixed the import for us and it says that it's a clean check. So let's run before push again. So again, we know lint passes. We know that ECS should pass, and we know that we've looked at PHPStan and we think that should pass, but actually it's found 2 errors. So this is where it's returning an array that we disagree with. It's not going to return an array in our instance. So here we would do, we would create a baseline. So we'll run PHPStan. We'll give it the memory limit, which just helps on larger applications to have a slightly larger memory limit. We use 4 gig. By default, I believe it's 2 gig. And we'll do generate baseline. So what this will do is it will analyze the code, it will run through, and it will generate a baseline that tells the system that there's some errors that we don't want it to look at. So let's go and take a look at the baseline file. And you can see here that it is very, very specific. It tells you the message that it's expecting. It tells you how many of them it's expecting and where it's expecting it for each one of the errors. So that would solve this. And if we run the before push, we'll now see that all of these pass, and it will move on to the next step, which is our tests. Now, in this instance, it's going to run in parallel with one process because there's literally 3 tests. We would normally be looking at this to cover every single item in code as much as it can be covered. For simplicity's sake at the moment, I simply wrote 3 tests. And if we look at these tests, they're relatively simple tests. And that is here. And we'll see that it's basically testing that Bootstrap works, that it's testing that it won't halt on a plugin that doesn't exist, and it's testing that the middleware is available. So we've normally been building out tests for every single instance of what we're looking at. To give you an example, let's go back to the articles table. Over here, we'd be looking at our setup here. So get by slug, we'd create a test that would use a factory to create an article. And we'd have that factory with a slug that is predefined. And over in our factories, you can actually see the factories there. So we have a default template using Faker that will build up our factory, and it does a string replace on the title that it's got, which in this instance is a sentence of 6 words. And this will strip out anything that is a special character, and it will replace the spaces with dashes. It'll also generate 3 paragraphs as text for us, and it will set the published flag to true. So if we were to go through, we'd use the factory to create us an article entity. We would then run on that article. We would then run get by slug on the repository, and we'd expect that to return the article that we're expecting. But we would also have the inverse test. We'd have the test that this would return null in that instance, that the article couldn't be found. And that would then mean that this was covered with both possible routes. But we'd also go a step further. What if the database failed? So we'd probably look to mock a failed database call and check that it handles that safely. And again, we'd do the same with user ID. In this instance, we'd look for, does it find 1? Does it find more than 1? And what does it do in the instance of none? So in the instance of none, we'd expect that to return an empty array, an empty result set. In all other instances, we'd expect it to return the number of articles with that user ID. The final one that we'd do here is get by ID. And again, we'd have tests of what if the database failed, finding one by the ID and not finding one by the ID. So that covers how we would use our standards. But I think for me, the important thing of standards is that it makes it easier for code to be passed between different people and for code to be used on multiple projects and for developers to move between projects. So previously we saw if I go to the login that it failed. And if I go to login now, we'll see that we can get there. We can go and edit our articles. We can change our tags, our titles, our body, and we can resave that. And we can see that the app now works in the way that we'd expect. And if we just create an article here, we can run that through, save the article, and we can see that that's present there. And if we go back to our home page, we should see that the article is now available on the front end, and we can go and view that article. So going back to our slides, what could go wrong with live code? Exactly the same things that could go wrong in development. And as I said earlier on, we'll look at things from the point of view of what if the developer that's been working on a project was not available tomorrow? We'll build everything in such a way as we can share across developers and we can work across teams and across projects in the best possible way. But there's actually more. This is only a part of the standards. We have standards that apply to every single part of our stack. Over time, these standards have evolved to cover not just how we code, but how we estimate, how we present to clients, how we manage our projects, and almost every other part of our business.